You know, is there life on Mars? It's one of the biggest questions we can possibly ask. And today, we're going to dive right into this decades-long investigation to try and find an answer. I want you to think of it like a cosmic detective story, full of clues, a ton of controversy, and yeah, a race against the clock for the final verdict.
So what if I told you that we might have already found life on Mars? Like almost 50 years ago? Yeah, this is the cold case, the mystery that's right at the heart of our entire story.
Okay, so here's how we're going to crack this case. First, we'll look at the cold case itself, Mars. Then, we'll get into what I'm calling the $11 billion answer. After that, we have to ask, what even counts as proof? And finally, we'll get into the race for the verdict.
All right, let's get into it. Part 1. Mars, the cold case. We're going to rewind the clock all the way back to the 1970s to a set of experimental results that have, believe me, split the scientific community right down the middle ever since.
So, picture this. It's 1976. Two NASA landers, Viking 1 and 2, touch down on the Red Planet. And they're carrying this really clever experiment called the Labeled Release, or LR for short. The idea was pretty simple, actually. Its job was to scoop up some Martian soil, feed it a kind of soup of radioactive nutrients, and then wait. Basically, listen for a radioactive burp. If it detected that gas, it would mean something in the soil was eating the soup and, well, breathing out. A pretty clear sign of life, right? And then, on July 30th, the first test came back, and it was positive.
And this is where the 50-year-long argument really kicks off. So on one side, you have the case for life. The evidence looked really good. Gas was released when they added the nutrients, exactly what you'd expect from tiny microbes. And when they heated the soil up to 160 degrees Celsius, hot enough to kill stuff, the reaction just stopped. Dead. But then, there's the case for chemistry. Scientists pushed back with some big counter-arguments. They said, hey, maybe there's just some weird, unknown, super-reactive chemical in the soil that's causing all this. And here's the kicker. Another instrument on Viking found 0 organic molecules. You know, the actual building blocks of life. But here's the real mystery, the thing that keeps this case cold. To this day, no one has come up with a purely chemical explanation that can perfectly replicate all of the results from that experiment.
And this quote from Gilbert Levin, the guy who actually designed the experiment, really captures just how certain he was. He said, when we got 4 positive responses supported by 5 different controls, that was when I really got excited. And you can see why. He was convinced he'd found life. I mean, the results came from 2 different landers, 4,000 miles apart. They were consistent, they were repeatable, and they ticked every single box that they had set out before the mission for what a positive result should look like.
So, okay, we've got this 50-year-old cold case on our hands. A result so confusing, it's basically haunted planetary science for decades. So how in the world do you solve it for good? Well, that brings us to part 2, the $11 billion answer. We're talking about the Mars Sample Return Mission.
And yeah, you are reading that number right. 11 billion, with a B, dollars. That's the high-end estimate for what it's going to cost to bring a few pieces of Mars back to Earth. This is so much more than just a science mission. It's a massive, monumental investment in trying to finally get a clear answer and avoid another 50 years of just guess. So how is this even supposed to work? Honestly, it's like the most audacious, complicated cosmic relay race you could ever imagine. So step 1 is already happening. The Perseverance rover is on Mars right now, drilling and sealing up these little rock samples. Step 2, a future lander has to show up, grab those samples, and launch them into Mars orbit with a tiny rocket. Then, step 3, an orbiter built by the European Space Agency has to find that little container floating in orbit and snag it. And finally, step 4, the orbiter flies all the way back to Earth and basically drops the samples off for a safe landing. Sounds simple, right? Well, not so much. An independent review board just took a hard look at the whole plan, and yeah, they found the mission is in pretty serious trouble. The report basically calls out a bunch of problems. Totally unrealistic expectations for the budget and the schedule right from the get-go, a really tangled and confusing management structure, and just a basic failure to communicate clearly why this whole thing is so important. In fact, the guy who chaired that review board, Orlando Figueroa, he put it about as bluntly as you can. He said, the report is emphatic in saying you started this effort under unrealistic expectations. Basically, he's saying the whole mission was kind of set up to struggle from the start because of fundamental flaws in the planning, which created this incredibly challenging environment for anyone to actually succeed. Okay,
But let's just say, for a second, that this mission does succeed. We get the samples back. Then what? How do we actually know if we found life? And that, right there, is the huge question at the heart of Part 3. What counts as proof? And trust me, it is way more complicated than it sounds. What the entire scientific community is searching for is something called a biosignature. The easiest way to think about it is like a fingerprint of life. It's any substance or object or even a pattern in the rock that could only have been created by something biological. This is the smoking gun everyone's looking for. But see, just finding a potential biosignature, that's not enough anymore. To avoid another 50-year argument like the one we got from Viking, scientists have put together this super rigorous checklist. They're going to ask a whole series of questions. First, is the signal you detected even real? 2, do you actually know what it is you're looking at? And 3, this is the big one. Is there any way something non-biological could have made this? Then they'll ask, does it even make sense for life to produce this thing in this particular Martian environment? And finally, they're going to demand multiple, totally independent lines of evidence, all pointing to the same conclusion.
So what's the big takeaway here? It's that we're moving away from the idea of a single eureka moment. A scientist in a lab coat shouting, "I found it!" The real goal now is to patiently build a case, to create a scale of confidence instead of a simple yes or no. And honestly, for a discovery this huge, that level of scientific discipline is absolutely crucial.
And all of this brings us to our final section, the race for the verdict. Because you see, this isn't just a purely scientific investigation anymore. Oh no, it's become a full-blown competition. So on one side, you've got the NASA and European Space Agency's Mars Sample Return mission, which is aiming for a launch sometime in the 2030s. But on the other side, you've got China's National Space Administration. They're planning their own sample return mission called Tianwen-3, and they're targeting a launch in 2028. And the strategies are totally different. NASA is all about retrieving those really diverse, carefully selected samples that Perseverance has been collecting. China's mission, from what we understand, is more of a grab-and-go kind of thing. Just get a sample from a single spot and bring it back fast.
This quote from Mars investigator Bruce Jakosky really just nails the tension here. He says, any sample is better than no sample. It becomes a political question of whether we want to let the Chinese scoop us. And that's the heart of it, right? From a pure science standpoint, the samples Perseverance has collected are probably way more valuable. But like he says, any sample is better than no sample. And suddenly the question isn't just about science, it's about politics. Does the United States want to be the second country to bring back rocks from Mars?
And that's just the new reality of the situation. This massive quest to answer one of humanity's oldest, most profound questions is now tangled up with national pride and the question of who's going to lead the next chapter of space exploration. The final verdict, whatever it is, carries a weight that goes far, far beyond the science lab. Which, of course, leaves us with one last, really profound question to think about. After all of the science, all of the engineering marvels, the politics, the billions and billions of dollars, if this whole cosmic detective story finally comes to an end, and we bring back definitive, undeniable proof of life on another world, are we as a species actually ready for what that answer means?